Okay, at the end of class, I gave you 3 sheets. This was the top one. So find it for me because we're going to do example 1, 2, and maybe 3 before the video runs out. So number 1 says you push with a force of 20 newtons on a 10-kilogram object at rest on a level surface. So draw your surface, draw your object. You're pushing with a force of 20 newtons. Usually I put my mass, 10 kilograms, here in the box. We know that Fg is going to be acting down, and we know that normal force is going to be acting up. Coefficient of friction between the object and the surface is 0.3, so mu is equal to 0.3, and friction would be acting this way. And the question wants to know, what is the force of friction that's opposing you? So you're pushing with 20 newtons, and it wants to know what is friction. So to find friction, and like I said in the last video, normally we start with some of the forces in the y direction. Is this object that's at rest on the level surface moving in the y direction? No, so AY is 0, so MAY is 0. So then we do some of the forces in the y. So what are the forces? There's an Fn, and there's an Fg, and that's going to be equal to 0. Fn is going up, Fg is going down, so it'll be Fn minus Fg. Take the Fg over, so Fn is equal to Fg, and we know that Fg is equal to mg. So we can find our Fn. It's 10 kilograms times 9.81 meters per second squared. So our Fn is 98.1 newtons. So now that we have our Fn, we can find our friction, because we know friction is equal to mu Fn. Mu, they told us, was 0.3. So 0.3 times 98.1. Friction then is going to be equal to 29.43 newtons. Okay, this is static friction. How do I know that? Because 1, it says example 1, static friction, and 2, because it says object at rest. So this is the static frictional force. Now, if it had asked you, like, what was the acceleration, you would do some of the forces in the x direction. But this force that we find with mu Fn for static is the maximum static frictional force that the surface can apply. Remember when we were doing the static frictional notes, I said it varies up to a maximum. So the maximum is the 29.3. So I push on a box with 20 newtons. What's the static frictional force that's going to push back? It's going to be 20 newtons. It's not going to be 29.43 newtons. Because if it was 29.3 newtons, I would look like the biggest loser in the world, because the box is stationary and I push with a force of 20 newtons, and now the box begins to slide in the opposite direction that I'm pushing in. Okay, so the static frictional force will only push back with as much as it needs to prevent the object from moving. So if I push with 10, it'll push back with 10. If I push with 20, it'll push back with 20. If I push with 25, it'll push back with 25. When I push with 29.43 newtons, now the box will just begin to move. The static friction will change to kinetic, and then the box will move because the kinetic's always less. Okay? Number 2, and I can talk about that again in class if that doesn't make sense to you. You push with the force of 200 newtons on a 50-kilogram crate and are able to get it to just begin to move. So whenever you see the words just begin to move, it means it's not moving yet, that its acceleration is still 0. So you're pushing with a force of 200 newtons. It's a 50-kilogram crate. Fg is acting down. Fn is acting up. Friction is going to be acting back this way. What must be the coefficient of friction between the crate and the floor? So we always start with some of the forces in the y. This crate is not floating up into the air, and it's not falling into the floor, so the AY is 0. So it'll be Fn minus Fg equals 0. So Fn will equal Fg will equal mg, and so we can find it. Fn will equal, mass was 50 kilograms, g is 9.81 meters per second squared, so the Fg is 490.5 newtons. Fn, excuse me. Fg is 2. Okay? So now we want to know what is the coefficient. So we know we could find the coefficient from our Fun equation. And we have our Fn, we're looking for our mu, but we don't have our friction. So we can't use this equation yet. Instead, we need to go to sum of the forces in the x direction. And when we do sum of the forces in the x direction, it says just begins to move, means A, it hasn't started to move yet. So whenever you see that just begin, Ax is 0. What are my forces? Well, there's an F going one way and a friction going the other. So F minus friction will equal 0, which means F equals friction. And we're told in the question, I'm pushing with 200 newtons. So friction then must also be 200 newtons. So then we come back to this equation and we can solve for our mu now. It's going to equal friction divided by the normal force. So 200 newtons divided by 490.5 newtons. The newtons cancel and you get 0.40775. Now when you're solving for mu's, please do not round this to 0.4. When a number is really tiny, rounding becomes really significant. So always for coefficients, keep 4 or 5 decimals, okay? All right, turn the page. Not to number 4, to number 3. Our horizontal force of 90 newtons, and this time it's kinetic, it means the object's going to move. A horizontal force of 90 newtons is required to pull a child on a sled at a constant speed over dry snow to overcome friction. So here's my force, 90 newtons. Fg will be acting down, Fn will be acting up, and yes, you need to draw these. No, it's not that I'm just doing it because I'm bored. The child and the sled have a combined mass of 60 kilograms. Calculate the coefficient of kinetic friction between the sled and the snow. Required to pull a child at a constant speed. Constant speed means Ax will be 0. Its speed is not changing. So again, you start, sum of the forces in the y is equal to MAy. The kid and the sled are not going up into the air. So it means Fn minus Fg must equal 0. So Fn must equal Fg, and we know Fg equals mg. So Fn equals 60 kilograms times 9.81 meters per second squared. So Fn equals, what is that, 588.6, I think, newtons. That's my Fn. We want mu, but we can't get it yet. We can't do friction is equal to mu Fn yet because we want mu, but we don't have friction. So we go to sum of the forces in the x direction is equal to max. So again, it's F minus friction is equal to, and it says that constant speed, which means this goes to 0. So once again, F is equal to friction is equal to 90 newtons. It will not always be this way, I promise. So mu is equal to friction divided by the normal force. So 90 newtons divided by 588.6 newtons. And you should get a mu of 0.15291. Okay, so your 3 steps, sum of the forces in the y direction, sum of the forces in the x direction, and friction equals mu Fn. And which one of number 2 and number 3 you do first depends on what they've given you. Okay, so maybe try number 4. This time the A isn't 0, but see if you can do it. And then go and do the textbook ones on page 144 that you probably wouldn't have been able to do before this. So number 4 and on page 144, numbers 5 to 8. Okay, very good.